Exponential and logarithmic equations. 1. Solve for x. So we look at this exponential equation, 3 to the x equals 12. So we want to decide what x is equal to make this happen. Well, it's always good to kind of give an estimate in your own mind. So if you're way off with your answer, you could check. So what about would x have to be? Okay, if x was 2, for example, 3 squared is 9, so it must be bigger than 2. And then 3 to the third power is 27, so it's got to be somewhere between 2 and 3. So we'll kind of double check our answer to see if it makes sense. So we're going to take ln of both sides. Ln of 3 to the x power equals ln of 12. And now we're going to use rule property number 3 of logarithms, that if you have ln of 3 to the x, you can pull the x out in the front and get x equals ln of 3 equals ln of 12. Now to get the x by itself, what do? That's right, divide both sides by ln of 3. And we get x equals approximately 2.26. And it does fall between 2 and 3. And you could double check it by raising 3 to that power, and you should get close to 12. If we wouldn't have rounded it off so much, you'd get exactly 12. Number 2, solve for x. 2 to the e to the 3x minus 1 power plus 5 equals 17. So what are we going to do first to get the x by itself? That's right, subtract 5. So then we get 2 to the e to the 3x minus 1 power equals 12. And then what are you going to do? That's right, divide both sides by 2, and you get e to the 3x minus 1 equals 6. Now we got the same problem again. We need to pull that exponent out of there so that we can deal with it in a normal way. So we're going to take the natural log of both sides. And when we take the natural log of e to the 3x minus 1, 3x minus 1, now this looks a little strange, but ln and e to some power, those are inverse operations of each other. So the ln undoes the e, so they just disappear, and you get 3x minus 1 equals ln of 6. You didn't have to make them disappear, but since they do when you use ln and e, then we'll do it this way. Otherwise, you could sort of repeat what we did in example 1. In fact, you could do both these problems using logs. You wouldn't even need to use ln, but this works out best. So then we add 1 to both sides. Now when we divide by 3, we get x equals 0.9306. I've rounded that off, and maybe 0.93 would even be a nicer place, but I thought it looked kind of nice that way. So we get 0.9306 is the x value that if you put it in the equation will make that left side turn into 17, so it'll be equal to the right hand side. Problem 3, solve for x. 2 ln of the quantity 2x plus 3 equals 24. Well, this is a little different. It's not an exponential, it's a logarithmic equation. So now we can see how we might solve a logarithmic equation. So what would you do first? You divide the 2, so you get just an ln of 2x plus 3. Dividing 2 by both sides, you get ln of 2x plus 3 equals 12. Now we got to get rid of the ln. But we know the inverse function for ln, it's e. So we're going to raise e to the ln of 2x plus 3 and e to the 12th. Those still should be equal. So we did that, even though it looks a little strange. But e to the ln will get rid of each other, so you have 2x plus 3 equals e to the 12th. And it's pretty straightforward from there. Subtract 3 from both sides, divide by 2, and you get approximately 81,375.90. And if you plug that number back in place of x in the original, you'll get pretty close to 24. And if you don't round it off at all, your calculator will come out that it's exactly 24. So we've done 2 exponential equations and one logarithmic equation.